Hello, and a very warm welcome to today's Nucleic Acid Insights webinar, titled Simplifying the Transition from R&D to GMP-Ready LNP Production. I'm Roisin McGuigan, an editor at Bioinsights, and joining me today I have Ben Knappett, who will explore how to simplify the transition to GMP and ensure consistency. After the presentation, we'll have a live Q&A session. So we invite our audience to pose their questions to Ben using the Ask a Question box at the bottom of your screen, and we'll try to get to it during the session. And now I'd like to introduce our presenter. Ben received his degree from Durham University before completing a PhD in nanoparticle synthesis and characterization at the University of Cambridge. He joined Particle Works in 2016, developing nanoparticle and microparticle products using microfluidics technology, which covered a wide range of material types. So without further ado, I'll now hand over to Ben, who's going to kick us off with his presentation.
Hello, everybody, and thank you for taking the time to join us today for this webinar. As I said, my title for this talk is Simplifying the Transition of from R&D to GMP for LNP production, taking a look at the Sunny Suite instruments from Unchained Labs. So when you go on holiday and you're heading down to the beach looking for a deck chair, there is an order to the way you do things. Firstly, we apply sunscreen. Then we search for the perfect patch of sunshine, and then we settle down to sunbathe. And I'm going to talk to you today about how that same series is applicable to the development of our mRNA LNP drug development with the Sunny Suite. So let's take a look at that mRNA LNP drug development process. So starting with preclinical development, there are a series of different stages that we need to consider when formulating an LNP product. First, we need to screen different formulations to identify which components are going to come together to form the best performing particle for our application. And then we after that want to look to optimize our formulation with the best possible process. So we want to tweak and tune our synthesis process to make that formulation in the best way possible with a view towards transitioning to a continuous production process. Before we move towards clinical trials, we're also maybe likely to want to produce some slightly larger volumes of material to do some more involved testing and characterization before our clinical trials. When it comes to clinical trials, we need to start considering injecting our developed materials into humans. And as we move through the different phases of clinical trials, we're going to progressively introduce a wider population of individuals to our drug products, right the way through to ultimately commercially manufacturing that and delivering to a wide population of people. At this point, we need to implement some strict controls over the manufacturing process for our materials, and that's where GMP comes in to help make sure that the materials that we're producing, intended to be delivered into humans, are produced in a controlled manner, in a controlled environment, and meeting all necessary regulatory requirements. So each of these different stages of development has a different set of requirements, might be taking place in entirely different laboratories or even sites or countries. And so the requirements that we need to consider at the different stages ideally need to mesh together so that we can have some continuity between our development process. At the screening stage, we're going to be concerned about trying to keep our per experiment costs low, as well as reducing consumption of material. These are typically very expensive constituent components, particularly the RNA, which may well be in-house synthesized at great efforts. And so we need to make sure that our process is as efficient as possible and as time efficient as possible as well. It takes a long time for individuals to prepare all of these different formulations with different approaches. So being efficient with the time that you invest in the lab is also key. When it comes to optimizing, the flexibility of our approach becomes key. We want to be able to work at different sets of flow conditions. We want to be able to optimize our ability to bring fluids together with different mixing geometries. And also we need to be flexible in terms of scale, producing anywhere from still quite small volumes of material up to particularly large volumes for further downstream testing. And of course, then when it comes to clinical trials, we want to be able to easily transfer the process that we've developed into a GMP laboratory, meeting all the necessary requirements. So let's take a look from the beginning of that. So we'll start with screening. And when it comes to screening, the formulation is the key aspect that we are looking to probe. Typical LNP formulations, as established in recent years, involve typically 4 or 5 component mixtures involving structural lipids to help stabilize the particle overall, ionizable lipids, which play a key role in binding our RNA and also are intrinsic in the release mechanism of these particles. Cholesterol as well is added in significant volumes to these particles to add bulk and structure to the particle. And our pegylated lipids are present at the surface of the particle to stabilize our particles in solution, both protecting the RNA from the body's immune system and also protecting the body from unwanted side effects by exposure to a foreign RNA. In addition to these components, there's an increasing volume of research looking into adding additional targeting moieties and whether these are functional groups that are bound to one of the existing lipid types or an additional material added altogether. Ultimately, this means that the formulations we're dealing with are really rather complex, and there's a lot of variability in the different parameters we can control. So if we're looking to screen to optimize for a particular performance characteristic or several different performance characteristics seen together, there are a huge number of potential levers that we can pull, whether that be changing the type or concentration of any of those lipids mentioned on the previous slide, whether that be changing the cargo we're looking to encapsulate to generate lipid libraries of different mRNA formulations. We can change the concentration of cargo, the length, or the sequence. In addition, there are various other process parameter considerations that we are able to tune, like what mixer type we use, the flow conditions we use for screening, as well as then things like our N to P ratio, and even nuances around the buffer we use, what pH and concentration that buffer is at, as well as whether or not we introduce any inline dilution or dilute subsequently, and what buffer do we dilute with. There's so many different potential variabilities here. So there is a need to be able to very rapidly screen this parameter space whilst being efficient with our materials, our running costs, and our human time costs, in order to quickly focus in on our leading candidates to be taken through for further development. And we do that with Sunscreen. The Sunscreen system is a 96 well plate based for inputs and outputs, and allows you to run up to 96 formulations in less than 6 hours, or at a rate of around an experiment every 3.5 to 4 minutes if you're running fewer than 96 formulations. Those formulations can be as little as 100 microliters per input, which means for a typical experiment with a 3:1 flow rate ratio, we're looking at a 400 microliter minimum experiment volume, anywhere up to a total of 2 milliliters, which is the maximum volume of the input and collection plates. The system's capable of operating at flow rates between 0.1 up to 30 milliliters per minute, and features reusable glass microfluidics, which means your per experiment running costs are extremely low because that same glass microfluidic mixer can be used for every single one of those 96 experiments with an automated wash cycle in between each experiment. So at the end of your run of 96 formulations, your microfluidic sunny is left clean and ready to use again for the next day of experiments. So all of the materials and tubing and components in the setup of this system are completely cleaned in place and reused, except for the well plates, of course. So this system, as you can see from the data on the right-hand side here, when you use it to run 96 formulations, we can see a very, very high level of consistency. So in that set of 96 experiments, 90 of them, the green data points, are identical repeats of one another using a DOTAP formulation. The pairs of three experiments where you can see the red bars are where we've intentionally left out the pegylated lipid to simulate a pore formulation. And you can see obviously our size has skyrocketed and our PDIs are very high. So not only can you see that the variability of the consistent and identical formulations is excellent within less than 1% CV between all of those experiments. When we have a pore formulation, our inline automated washing completely cleans the system of the pore formulation, and immediately we return for the next formulation straight back to high quality, consistent LNPs. And you can see an example from the little video that's playing on the bottom corner of what that experiment looks like. Our system is filled with driving fluids, so typically ethanol and buffer, and these are pumping through the system all the time whilst the experiment's running, and we introduce our small volume of sample, represented by the green and blue dyes here, using sample loops and valves that are built into the fluid handlers. So we're releasing a small portion of reagent into the flow path as the experiment runs, and then capturing that reacted sample in a collection sample loop before dispensing it onto our collection well plate. And that exact process then repeats for as many times as you've requested. All of the parameters that you can control for the process are variable per experiment. So you can simply define your experiments in a easy to use Excel spreadsheet that has built-in validation, and each experiment can have a different set of flow rates, a different set of head and tail cut conditions, and different ratios if you wish. So truly 96 completely unique formulations, both with reagents and process variables. So with this system, generally speaking, you can use around 50% less reagents, have around 90% less hands-on time at the instrument due to its walk-away automation, and eliminate the need for single-use consumables, which ramp up per experiment costs. Now, when you pair that capability with a stunner, the stunner is our 96 well plate based DLS and UV-Vis instrument. We're able in a single day to get size analysis and PDI of our samples, as well as RNA quantification data from UV-Vis in a single working day. The stunner data allows you to not only probe particle size, but also now particle concentration. So in combination with having a quantified particle concentration and our quantified RNA concentration from the UV-Vis, we're actually able to also estimate a typical particle loading. So we can get an estimate of the number of RNA molecules per particle. So the new upgrades to Stunner add a whole bunch of additional insights as well to aggregate detection by measuring at multiple angles, as well as all of the original fantastic benefits of the Stunner instrument. So what does that look like in practice? Well, we can now take 96 experiments and run those in a fully automated run. Here we've done that with 32 formulations, each run in triplicate, and we've varied a bunch of different formulation parameters. We've varied the PEG lipid mole percent, as well as the identity of the PEG lipid between two different types. We vary the structural lipid, the cationic lipid, and the pegylated lipid used. So you can see from the initial data presented here some of the more obvious trends. As we increase the mole percentage of our PEG lipid, we see a decrease in particle size, and that's present across all of the different component variabilities. So we see expected trends, but there is so much more data that you can extract from a large data set like this. So if we take a look at a couple of examples, you can really hone in on performance sweet spots by starting to identify trends between, for instance, the effect of the structural lipid used on the PDI. So you can see that typically when we use DSPC as our structural lipid, we're seeing lower PDIs in general than when we use DOPE. On the right-hand side, you can see the effect of changing the cationic lipid on the particle side, on the Z average. And interestingly, you can see that for most of the different formulation combinations, wherever we use DOTAP, we tend to get a smaller particle size than when we use DDAP. However, that's not true when you use DOTAP in combination with DOPE and DMG PEG 2000. Actually, you can see here the size increases slightly. So there is a lot of nuance to how these particles, different formulation components, interact with one another. And by being able to do a much larger number of experiments using material more efficiently and saving you a lot of time, we're able to give you much more significant insights on the formulations that you're optimizing in order to find those perfect particle formulations. Once you've identified a few selected formulations that are giving you the performance that you require, it's time to start thinking about process optimization. And for that, we use our Sunshine instrument. Sunshine operates in a similar manner to Sunscreen, able to do a series of automated experiments. This time, though, we're injecting a single pair of reagents into our larger sample loops, and then the system will run experiments just like you saw in the video on the previous slide, except we're releasing a small portion of the injected reagent each time we run an experiment, and we can do things like screen total flow rates or automate repeats. So we're able to do a series of automated experiments from that single injection, all of which are automatically collected using our collector module. The system is capable of running formulations from as little as 1 milliliter of reagent, all the way up to continuous flow. The system can be run in 2 different modes of operation. So first, you can optimize your process conditions, explore using different Sunny mixer types, explore different flow parameters to hone in on the best results when making particles from your given formulation. And then once you're ready to produce larger volumes, you can set the system up to pump in continuous mode, allowing you to collect much larger volumes of material. The system uses the same reusable microfluidics, which I'll come on to again in a moment, and also has direct protocol transfer capability from Sunscreen, meaning we can take any experiment that you ran on a Sunscreen, put those same parameters onto our Sunshine instrument with the same Sunny and the same reagents, and achieve the same particle size and performance results. On those Sunnies, we have the same Sunny mixer geometries for all of our systems, meaning that the mixer types you use on one are directly transferable to others. They're made out of glass with pristine microfluidic channels, which have been wet etched and bonded together to form sealed channels. You can use these in GMP environments as well. We have a range of Sunnies that are suitable for use in GMP. And depending on what you're currently working on, what your objectives are for your stage of development, you can use different mixer types potentially. So the Sunny Trident T has reverse angle mixing and built-in inline dilution. It has a wider channel diameter, which makes it great for screening different formulations, where we perhaps want to have access to the full potential range of flow rates from the system. And also, if you do have those bad formulations where you do get precipitation or aggregation, the wider channel is easier to clean, less prone to blockage, and allows you to explore further the different formulations without fear of getting a blockage. If you do get a blockage on the Sunny, it's very easy to simply pause your experiment, reinitialize, swap for a clean Sunny, and then just resume from the very next experiment in your spreadsheet. So you don't have to start all over again. You still use all of the rest of the formulations you prepared. That whole process can take around 5 minutes. If you want to use a different mixer geometry as you're starting to optimize, our Sunny X and Sunny T geometries offer cross and T type mixing at a range of different channel sizes. So we have these in 100 microns, 190 microns, and 275 microns, which is another lever that you can pull to control things like particle size, as well as accessing higher throughput flow rates. So with the Sunshine system, you're able to then explore your parameter space to perfect the production of your particles. So the data on the left-hand side here shows 3 repeat experiments carried out on Sunshine, automating experiments at 4 different flow rates in each of those runs. So an experiment at 5 milliminute, then 7, 9, and 12 milliminute. And you can see the 3 repeats plotted here, showing high consistency between the independent runs, and also showing nice particle size control as we vary our total flow rate. So honing in on a desirable size in PDI, identifying the correct mixer to use, and then once you've established the perfect formulation and the perfect parameters, you can turn on the taps in continuous mode. And as you can see from the data on the right-hand side, we get nice consistent particle size and PDI across a run when we choose to fraction collect that and investigate each individual collected fraction. Then, once you've finished with your preclinical optimization, the time comes for production in a GMP environment. Typical GMP equipment on the market at the moment tends to have quite a high focus or strong focus on high scale, high volume production. Typically, in order to achieve those higher production flow rate volumes, a different pumping technology or mixer size may need to be implemented. And also, the use of single-use flow paths can add quite a high level of cost, certainly when you're first entering clinical trials, needing to use a single flow path each time, even when your material volume throughput requirements are relatively low, can be quite a high expense. So when you're just setting out into clinical trials, the typical requirement is likely to be to produce hundreds of milliliters to a few liters, maybe tens of liters of LNPs. And for many applications, that will be suitable for clinical trials, but also potentially even for early manufacturing. Certain applications with more niche applications and audiences may require smaller volumes, even in commercial manufacturing. Ideally, you want the transfer from preclinical equipment to be a very simple and easy one. And the best way to do that would be to have a consistent mixing process between the preclinical and the clinical equipment. And ideally, flexibility of the flow path use to avoid excessive costs is desirable, so that we can potentially reuse a flow path in the early development stages whilst having an ability to fully replace it later down the line. So Unchained, we feel that GMP shouldn't be a difficult process, so we're here to make it as easy as possible for you with Sunbather. Sunbather is our GMP-ready LNP producer. It can run at flow rates of 10 milliliters a minute per channel, up to 1.8 liters an hour with a typical configuration. We have inline dilution, just the same as with the rest of our systems, and a fully replaceable wetted flow path as well. We have the same range of different mixer types that can be used on our other instruments, as well as 21 CFR Part 11 compliant software and direct process transfer from sunshine and sunscreen from a preclinical setting. The flow path comes in 1 or 2 sunny configurations, depending on the process that you optimized in your preclinical development work. So that means we can use either one chip, whether that be a Trident chip that has inline dilution built into it, or something like a Cross and a T sunny in order to have inline dilution at a second junction. The system has fully traceable wetted materials, the majority of which are USP Class 6. And we also provide extractables, bioburden, and endotoxin data with the flow path. You can then choose to either reuse or replace the entire flow path as required. So the system can be sanitized. We have sanitization SOPs available for customers, allowing you to clean and reuse the system flow path as needed. But when it comes to it, you can remove all of the components of the wetted flow path and replace them entirely. In order to ensure that you are able to meet all the regulatory requirements for the production of your materials as easily as possible, Sunbather has it covered when it comes to supporting data. Whether it's the software, hardware, or the system consumable, we have documentation to support you. Our equipment manufacturing is underpinned by a robust quality management system, and our quality team are available to help provide the information and documentation that you need if a supplier audit is required. At installation, an IQ/OQ is provided, and detailed user training will ensure that you are up and running in no time. Sunbather software has been designed to work with an IP66 rated touchscreen interface with a stainless steel enclosure and generates a full audit trail of process critical actions. Both administrator and operator access levels are available, and the operator is prompted for a digital signature for process critical actions. You can see here a run parameter setup screen. You can simply tap to enable the channels that you wish to run, enter the flow rates you would like to pump at, define a total volume and a batch ID. And once you've initialized the pumping channels, the system will show a green start button and you're able to simply click start. At that point, the operator will be prompted for their password to sign off that process critical action. And the fundamental key principle of this system is that we have direct, consistent, continuous production capabilities, both with Sunshine and Sunbather, which means anything that you developed in that pre-clinical environment can be directly transitioned to our Sunbather instrument, same sets of flow rates and process conditions, meaning we eliminate the need to re-optimize and revalidate for an entirely different high volume production scale straight out of the gate. And if you do want larger production volumes, you can number up your Sunbathers. By running multiple systems in parallel, you scale out your process and are able to reach larger production volumes without needing to fundamentally re-optimize the process by which you're making particles. So you can have that same confidence that at each of those microfluidic junctions, you're producing high quality particles, and you can choose to either QC those batches individually and combine them, or to collect into a single batch and QC after combination. And so this is the start to finish development process using the Sunny Suite. You now can go right the way from screening only a few hundred microliters of formulations on a 96 well plate format with complete walkway automation, through your optimization and process development from anywhere from 1 milliliter to continuous production, and then take that continuous production process directly into a GMP environment with Sunbather, allowing you to engage in clinical trials all the way through to commercial manufacture by scaling up with parallel units. All the way along, we're using the same flexible mixing capabilities, saving you on time, money, and materials, going from with the same process and the same mixing to produce the same particles every time. And these systems have been designed and developed from concept specifically for the development of mRNA, LNP nanomedicines. So we have designed each of these with you as the end user in mind. And you really can trust that process from start to finish. So here you can see some data that shows that all of our systems produce consistent and high quality LNPs, whether that be on our Sunscreen system in its automated protocol mode, Sunshine in protocol or continuous mode, and Sunbather in its continuous mode. With these SM102 formulations that you see here, we get low PDIs below 0.1 and consistent particle size at the target we chose of 100 nanometers. So we're very pleased to introduce Sunbather to the Sunny suite of instruments, and I look forward to taking any questions that you might have about any of these instruments. Thank you very much for taking the time to listen.
Thank you, Ben, for a great presentation. We now have time for a quick Q&A, if you'd like to join me back on camera, and I hope you're ready to answer some questions.
Absolutely.
Wonderful. So first up here, I have the first question. Do I need to change the Sunny every time if I reuse the tubing kit?
Good question. You do not have to. You can include the Sunny in the clean in place procedure. For many users, we expect that the Sunny is obviously the main point of combining the fluids together, is the narrowest constriction point in the system, and it might be considered good practice to replace the Sunny each time. But there is no obligation to do so. So if you want to do that, you can. But also it can be incorporated directly into the clean in place process.
Great, thank you. Next question here. How long does it take to assemble the flow path?
So flow path assembly is fairly rapid. Assuming this is for Sunbather, the process of assembling the tubing kit onto the system maybe takes 10 or 15 minutes. For our other instruments, the same is true. Sometimes they take just slightly longer in terms of routing the tubing tidily through the system flow paths, but the replacement of the tubing on other systems is a much less frequent occurrence anyway, as the whole thing's cleaned in place between each experiment.
Fantastic, thank you. A related question here. This is in several parts, so bear with me. Is the flow path fully pre-assembled and sterilised? How long does it take to install the flow path? And does the flow path include single-use pumps?
So let me take those in order. So remind me the first question.
Sure. So is the flow path fully pre-assembled and sterilised?
So the system comes double bagged and is not sterile, but requires sanitization in place. So obviously, as part of being reusable anyway, if you've used the system once, that sanitization process would be the same one that you used at the beginning as you would use before you reuse the system as well. So the system's partially assembled. So some components are assembled, but there is a degree of user assembly required, and that's what takes the kind of 10 or 15 minutes or so in the assembly process.
Okay, great. So that answers part 2. And then part 3 was, does the flow path include single-use pumps?
Right. So the syringes and the valve block are removable from the front of the system. So the pump drives are built into the system. So the pumps themselves are not replaced, but the wetted components are. So in releasing this product, the visual change you might notice between the sunscreen and sunshine instruments to the Sunbather instrument is that there's the valve block has been adjusted to move the mechanical components into the body of the hardware, so we're reducing the cost of the replaced component. So that's just the rotor on the front. The other thing is the pressure sensor has been removed and replaced with an internal strain gauge, which still monitors the running pressure of the system, still gives us the same ability to recognize overpressure errors, but reduces the cost of replaceable components in the flow path.
Fantastic, thank you. I think we can fit in one more question, but to our audience, any questions we can't get to during the session, we can reply by email. So if you have any more questions, please do keep them coming in. So finally, do you see chip blockages when running different formulations on sunscreen and sunshine? And how do you fix this?
So blockages are certainly a consideration for microfluidics. You're using small channels, and so the preventative methods to sort of stop blockages happening are obviously good hygiene with your fluid preparation and filtering things to make sure that you're putting nice clean fluids into the system. If the formulation you're using is a particularly unstable one or causes some rapid precipitation within the mixer, it's possible with the smaller geometries or more complex mixing geometries like our micro mixer that you could find that you end up with a blockage. Now, what the system will do is it will just register an error. It will tell you that there is typically an overpressure error, which it'll stop the system. You can diagnose the issue very quick. It's 10 or 20 seconds to swap out the sunny for a clean one. And then you can simply reinitialize the system and resume your automated set of experiments for either sunscreen or sunshine from a particular experiment number. So you can if you had an error on experiment 36, you can resume from 37 and get going again within 5 minutes or so. And then we also provide the system with a chip flushing kit, so you can then take a look at the sunny you removed, and you can use the flushing kit to clean it out and try and remove that blockage.
Wonderful, thank you. Well, thank you, Ben, for answering those questions. I'm afraid that's all we've got time for today. But as I mentioned, any questions we didn't get to, we will reply by email. And the webinar will be available on demand from tomorrow. So look out for an email from us with the link. All that's left is to thank Ben once more for his great presentation, and thank you to the audience for listening. We hope you'll join us again soon.